A greenhouse gas. Methane. Without greenhouse gases, the average temperature of Earth's surface would be about -18 degrees Celsius, rather than the present average of 15 degrees Celsius. The atmospheres of Venus, Mars and Titan also contain greenhouse gases. Human activities since the beginning of the Industrial Revolution have increased the atmospheric concentration of carbon dioxide by almost 50%, from 280 ppm in 1750 to 419 ppm in 2021. The last time the atmospheric concentration of carbon dioxide was this high was over 3 million years ago. This increase has occurred despite the absorption of more than half of the emissions by various natural carbon sinks in the carbon cycle. At current greenhouse gas emission rates, temperatures could increase by 2 degrees Celsius and natural gas, with additional contributions from deforestation and other changes in land use. The major constituents of Earth's atmosphere, nitrogen, are not greenhouse gases because molecules containing two atoms of the same element such as N2 and O2 have no net change in the distribution of their electrical charges when they vibrate. And monatomic gases such as air do not have vibrational modes. Hence they are almost totally unaffected by infrared radiation. Some molecules containing just two atoms of different elements, such as carbon monoxide and hydrogen chloride, do absorb infrared radiation, but these molecules are short-lived in the atmosphere owing to their reactivity or solubility. Therefore, they do not contribute significantly to the greenhouse effect and often are omitted when discussing greenhouse gases. Greenhouse gases are those that absorb and emit infrared radiation in the wavelength range emitted by Earth. Carbon dioxide, nitrous oxide, methane, and ozone are trace gases that account for almost 0.1% of Earth's atmosphere and have an appreciable greenhouse effect. The most abundant greenhouse gases in Earth's atmosphere, listed in decreasing order of average global mole fraction, are atmospheric concentrations are determined by the balance between sources. The annual airborne fraction is the ratio of the atmospheric increase in a given year to that year's total emissions. As of 2006, the annual airborne fraction for CO2 was about 0.45. The annual airborne fraction increased at a rate of 0.25 plus or minus 0.21% per year over the period 1959 to 2006. Oxidation of CO2. CO2 directly produces an unambiguous increase in radiative forcing, although the reason is subtle. The peak of the thermal IR emission from Earth's surface is very close to a strong vibrational absorption band of CO2. On the other hand, the single CO vibrational band only absorbs IR at much shorter wavelengths, where the emission of radiant energy from Earth's surface is at least a factor of 10 lower. Oxidation of methane to CO2, which requires reactions with the O radical, produces an instantaneous reduction in radiative absorption and emission since CO2 is a weaker greenhouse gas than methane. However, the oxidations of CO and CH4 are entwined since both consume O radicals. In any case, the calculation of the total radiative effect includes both direct and indirect forcing. A second type of indirect effect happens when chemical reactions in the atmosphere involving these gases change the concentrations of greenhouse gases. For example, the destruction of non-methane volatile organic compounds in the atmosphere can produce ozone. The size of the indirect effect can depend strongly on where and when the gas is emitted. Methane has indirect effects in addition to forming CO2. The main chemical that reacts with methane in the atmosphere is the hydroxyl radical. Thus, more methane means that the concentration of O goes down. Effectively, methane increases its own atmospheric lifetime and therefore its overall radiative effect. The oxidation of methane can produce both ozone and water, and is a major source of water vapor in the normally dry stratosphere. CO and NMVOCs produce CO2 when they are oxidized. They remove O from the atmosphere, and this leads to higher concentrations of methane. The surprising effect of this is that the global warming potential of CO is 3 times that of CO2. The same process that converts NMVOCs to carbon dioxide can also lead to the formation of Tropospheric ozone. Halocarbons have an indirect effect because they destroy stratospheric ozone. Finally, hydrogen can lead to ozone production and CH4 increases as well as producing stratospheric water vapor, the major non-gas contributor to Earth's greenhouse effect. Clouds also absorb and emit infrared radiation and thus have an effect on greenhouse gas radiative properties. Clouds are water droplets or ice crystals suspended in the atmosphere. Water vapor accounts for the largest percentage of the greenhouse effect, between 36% and 66% for clear sky conditions and between 66% and 85% when including clouds. Water vapor concentrations fluctuate regionally, but human activity does not directly affect water vapor concentrations.